Exercise 1.1, question 2. Show that any positive odd integer is of the form 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5, where q is some integer. Now, the first time somebody looks at this question, it just makes no sense whatsoever. It's like you're talking about numbers, it's an odd integer. How are you just getting into these Q's and 5's and 6's? Odd integers are just your 1, 3, 5, 7, and so on. How did those simple numbers become this? Well, this is just trying to tell you that no matter which odd integer you take, which odd positive integer you take, it can be expressed in this form. For example, if I take the number 17, then I can express it as one of these three forms. Let me see which one. Is it 1 more than a multiple of 6? No, it's not 16 plus 1. Is it 3 more than a multiple of 6? No, because that would mean 14 is a multiple of 6. But you will see this is 12 plus 5, where 12 is what? 6 times 2 plus 5. So I really could write this random odd integer that I took in the form 6q plus 5, where my q was 2. So this I checked for one number. You can check it for any number. But we have to show that this will always happen. Not by checking numbers, but by giving a concrete proof. And what you will need for that is the Euclid's division lemma that you've already learned. So to recall, whenever two positive integers a and b are given to you, you can divide a by b, and as a result you will get the quotient q and the remainder r, and they will all satisfy this equation together, because dividend is equal to divisor times quotient plus remainder. So for more detail on this, you can watch question 1 again if you're not very sure of this yet, and if you haven't watched it, I would suggest go back and watch that first. So let me clear up this space and let's start with the proof. Okay, so what you have to do is you have to start with any random odd positive integer, not by taking a number or anything, but by giving it a name. So I will say let a be the name of that positive odd integer. So let a be any positive odd integer. Now what I'm doing with this a is I will use the division lemma on a and 6. Why did I choose 6? You will get the hint from the question that you're doing. You just have to see this number that you have with q or whatever letter they might use. So all of these here mean this is 1 more than a multiple of 6, this is 3 more than a multiple of 6, this is 5 more than a multiple of 6. So that is where I'm getting the 6 from. Okay, so I'm taking a as this random number, and as I just said, I will take b equal to 6. So now that I have these two numbers a and b, I know I will get q as my quotient and r as my remainder, using which I will be able to write a is equal to bq plus r. But why do I say b? I already know the value of b. So I will instead write 6q plus r. And the rule that I know is that my r has to be greater than or equal to 0 and has to be less than the divisor, which is b here. That means it has to be less than 6. Now, how do you interpret this little part? What can the values of r be? So it can be 0, 1, 2, 3, 4, or 5. It cannot be 6 or more than that because it's less than that, right? And now since r has these 6 different values, I can write a also using each of these values of r one by one. So for example, if my r is 0, then I can say a is equal to 6q. And when r is equal to 1, then you will get a as 6q plus 1. With r equal to 2, you will have 6q plus 2. Similarly, you're going to have 6q plus 3, 6q plus 4, and 6q plus 5. So you see there are 6 possibilities because there were 6 possibilities for the values of r. But you will notice in the question you just had 3 of these. It was either plus 1, plus 3, or plus 5. How is that happening now? Well, that is happening because of this word here. You know that this number A that you've assumed is odd. It is an odd integer. Now, in this list of 5 possibilities, not all of them are odd. And the ones that are not odd, I will cancel them. I will reject them. For example, 6q, this is even. It is divisible by 2. I can just write this as 2 times 3q. Similarly, 6q plus 2 is also even. Why? Because I can write it as 2 times 3q plus 1. So this is divisible by 2. So this is also out. Similarly, 6q plus 4 is also out because I can write this as 2 times 3q plus 2. So overall, what are the possible values that I'm left with? It's just these 3 that can be odd. And you will see they exactly match with the 3 forms that we had here in the question. So we have proved what we had set out to prove.